Hello everyone. In this video we are going to solve past year CAT questions from the topic permutation and combination. It is observed that students are ignoring this topic because not a single question was there in any of the slot of CAT 2023. But remember everyone, CAT is a very unpredictable exam. It may possible that next year also there will not be any question from this topic, and it is also possible that next year there will be the considerable number of questions from this topic. Also remember the fact that in the exams like SNAP and NMAT, the questions from P and C are a very common type of questions, also in the XAT exam. So let's not ignore this topic and let's start solving the past year CAT questions. In this video we will start with the old CAT papers. So before you continue with this video, make sure you revise all the concepts from permutation and combination. Then whenever the question is displayed on the screen, pause the video, try that question by yourself, and then continue with the explanation video. So let's start. Here we will be starting from the old CAT papers. The first question is from CAT 1997. The question is, in how many ways can 8 directors, the vice chairman and chairman of a firm be seated at a round table if the chairman has to sit between the vice chairman and a specific director? So over here total how many people are there? 8 plus 1 plus 1, that is total 10 people are present. So it is a round table arrangement. So there are 10 places. Let's mark 10 places. So everyone here, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are the 10 places. So we want the chairman to sit in between a specific director. The director is specific. Let's call that director as D1 and a vice chairman. Vice chairman and the director D1 can interchange their places. So the condition is these 3 people are always seated together. These 3 people are always seated together. So consider these 3 people as a single object. And the remaining 7 directors are the 7 objects. Okay. So the remaining directors are D2, D3, D4, D5, D6, D7 and D8. So consider these 3 people as a 1 object and the remaining 7 directors are 7 objects. So total 8 objects are there. In a round table arrangement, 8 distinct objects we can arrange in 8 minus 1 factorial ways. And over here the director D1 and the vice chairman can interchange their places. So there are 2 cases. So our final answer is going to be 7 factorial into 2, that is option number C. The next question is from CAT 1998. How many 5-digit numbers can be formed using the digits 2, 3, 8, 7, 5 exactly once, such that the number is divisible by 125? So we want to form a 5-digit number. Over here we want to form a 5-digit number by using 5 digits. Using each digit exactly once, it means without repetition. It means we need to use all these 5 digits. All these 5 digits we need to use. The test of 125, 5 cube, is last 3 digits. The number formed by using last 3 digits should be divisible by 125. So last 3 digits, they can be 125 but 1 is not there. They can be 250 but 0 is not there. They can be 125 into 3, 375. Yes, possible. Then 125 into 4, 500. 0 is not there. 125 into 5, 625 but 6 is not there. Then 125 into 7, 875. Okay, 875 is the another possibility. That's it. So these are the 2 possibilities we are having for the last 3 places, everyone. So last 3 places we can fill in the 2 different ways. So out of 5 digits, 3 digits are consumed over here. Now 2 digits are remaining. So 2 choices over here, 1 choice over here, and over here there are 2 choices. So total how many such a 5-digit numbers we can form? Total 4 5-digit numbers we can form, which satisfies the given condition. The next question is from CAT 1998. The question is, how many 5-digit numbers can be formed by using these 5 digits without repetition, such that the unit place digit is greater than tens place digit? So look here, we need to form a 5-digit number, and there are only 5 digits given, that is 2 without repetition. It means we need to use all these 5 digits to form a 5-digit number. So over here, what is the condition? This is A and this is B. We want the unit place number should be greater than the tens place number. So what do we need to do over here? We are having a list of 5 digits. Out of those 5 digits, you need to choose 2 digits for the last 2 places. In how many ways you can choose, everyone? There are 10 ways. 5C2 is equal to 10 ways you can choose A and B. But now we need to arrange. For example, if you select 1, 5, you can place 1, 5, or you can place 5, 1. Which one is valid over here? We want B to be greater than A. We want second digit to be greater than first digit. So 15 is possible, 51 is not possible. So basically this is a kind of which arrangement? This is a kind of ascending arrangement. So choose any 2 digits out of 5 digits. In how many ways you can arrange them in ascending order? Only one way. So there are 10 ways in which you can select 2 digits, and for every way there is only one way you can arrange that, such that B is greater than A or A is less than B. So over here, for the last 2 places, how many choices do we have? We have 10 choices. So now out of 5 digits, 2 digits are used, 3 digits are left. For the first place 3 choices, second place 2 choices, third place 1 choice. So how many such a 5-digit numbers are possible? 60 is the answer to this question. The next question, again from CAT 1998. 5-digit numbers are formed by using the digits 0, 1, 2, 3, 4 exactly once without repetition. What is the difference between the maximum and minimum number that can be formed? So 5-digit numbers by using 5 digits without repetition. It means we need to use all the given digits. So the maximum number which satisfies the given condition is equal to 43210. And the minimum number which satisfies this condition is the first place cannot be 0. The first place has to be 1. Second place can be 0. Then 2, 3, 4. This is the smallest possible number which we can form under this condition. So we need to find the difference. This difference is going to be how much? Let's have a look at it. This difference is 10 minus 4 is 6. 10 minus 7 is 10 minus 3 is 7. Then 11 minus 2 is 9, 2 and 3. 32, 9, 76. Option C is the correct answer here. Question number 43. 10 points are marked on a straight line and the 11 points are marked on another straight line. How many triangles that can be constructed with the vertices from the above points? Let's have a look at it. This is first line and this is second line. So on this line total there are how many points are there? 11 points are there. On the second line total there are going to be 10 points. So now we need to draw the triangles. How many triangles you can draw? Let's have a look at it. Let's call this as line 1 and line 2. The first case over here is from the line 1 take 2 points, and from the line 1 take only 1 point. you will be able to form a triangle. How many such triangles you can form? 11C2 into 10C1, that is equal to 55 into 10, that is equal to 550. The second possibility over here is from L1 take only 1 point, and from L2 you need to take 2 points. So how many triangles we can form over here? From L1 we need to take 1 point, that is 11C1. From L2 we need to take 2 points, so 10C2. This is going to be how much? 11 into 45, that is equal to 495 triangles are possible in the second case. Is there any other possibility? Check. If we take all 3 points from any one single line, then we will not be able to draw the triangle, everyone. So these are the only 2 cases available. So our final answer is 550 plus 495. This addition is equal to 1045. That is option C is the correct option over here. The next question is from CAT 2000. There are 3 cities A, B and C. Each of these cities is connected with the other two cities by at least one direct road. If a traveler wants to go from one city origin to another city destination, she can do either by traversing a road connecting the 2 cities directly, or by traversing 2 roads, the first connecting to the origin to the 3rd city and the second connecting 3rd city to the destination. In all, there are 33 routes from A to B, including those via C, and there are 23 routes from B to C, including those via A. How many roads are there from A to C directly? So let's have a look at it. If you read this question carefully, you will come to know that the 3 cities A, B and C are in this manner. There are direct roads from each and every city to each and every other city. There are going to be direct roads. So let's have a look at it. At least one route is there in between any 2 cities. So let's say from A to B, the number of roads are P. There are going to be P roads. A to B is connected by P different roads. Then B to C is connected by, let's say, Q different roads. And A to C is connected by using, let's say, R different roads. Okay, everyone. So now, in how many ways a person can travel from A to B? If I want to travel from A to B, I can travel directly from A to B, or I can travel A to C to B. Okay, so A to B, in how many ways we can travel? P ways. Or means addition. A to C to B, A to C R ways, C to B Q ways. So in how many ways I can travel from A to C to B? I can travel by using R into Q number of ways. This addition is equal to 33. After this, there are 23 routes to travel from B to C. B to C direct, how many routes are there? Q. And we can also travel in this manner, everyone. B to A to C. Okay, B to A, how many different? B to A we are having P roads, A to C we are having R roads, so P into R. This addition is equal to how much? 23. So now over here there are 3 variables and there are 2 equations, so we will not be able to get a unique value of each and every variable. But to find A to C, we need to find how many direct roads are there from A to C. So we need to find the value of R, everyone, over here. Okay, we don't need the value of other variables, only R is sufficient. So over here we need to do the trial and error, because there are 2 equations but we are having 3 variables. We need to find the value of R, and the value of R is given in the options. So what will happen, everyone? Let's have a look at it. if you put the value of r to be 10, let's start with the greater value, that is 10. If r is equal to 10, you can see that the value of p is going to be 0 or 1 or 2. Q is equal to 0, no, p is equal to 0, 1 or 2. Then the corresponding value of Q will become how much here? 23, 13 and 3. Any of these combination will it satisfy the first equation, P plus R into Q is equal to 33? No. After that, if the value of R is equal to 5, then let's write the combinations for P and Q. Then if P is equal to 0, Q will be 23. If P is equal to 1, it is 18. If P is equal to 2, it is 13. If P is equal to 3, it is equal to 8. If P is equal to 4, it is equal to how much? 3. So any of these combinations satisfy the first equation. Let's check. P plus R into Q is equal to 33. There is no any combination which satisfies this, so option C is eliminated. After that, the next we'll check option A. So let's have a look at it. Option A says that the value of R is equal to 6. If you put R is equal to 6 over here, the value of P can be 0, value of P can be 1, 2 and then 3 and then 4. 4 is not possible. So if P is equal to 0, R is equal to 6, Q will be 23. This is incorrect. This will not satisfy the first equation. If you put P1, R 6, the value of Q will be how much? 23 minus 7, that is equal to 17. It does not satisfy the first equation. If R is equal to 6, P is equal to 2, 6 to the 12, 23 minus 12 is 11. This also does not satisfy the first equation. And the next you can see over here that if you put R is equal to 6, P is equal to 10, then Q is equal to 5. And this will satisfy the first equation, everyone. So over here you can mark option A, 6 as an answer to this question. Question number 41 from CAT 2000. Okay, Sam has forgotten his friend's 7-digit telephone number. This is a 7-digit telephone number. He remembered the following, the first 3 digits. First 3 digits, there are 2 choices, 635 or 674. The number is odd number, means unit place should be 1, 3, 5, 7, 9. In the number 9 appear once, the other digits they can appear any number of times. So repetition of any other digit is possible, but repetition of 9 is not possible. If Sam were to use a trial and error process to reach his friend, what is the minimum number of trials he has to make before he can be certain to succeed? So let's have a look at it. So over here for the first places we are having 2 possibilities. 9 appears exactly once, everyone. So first case, over here we need to form the cases. First case, 9 is at unit place. First case is 9 is at unit place. So over here first 3 digits, first 3 places we can fill in 2 different ways. So over here 9 cannot come, 9 cannot come, 9 cannot come. So 9 into 9 into 9 possibilities. In the unit place 9 is compulsorily there, so only one choice. So 729 into 2, 1458 is the answer for the first case. In the second case, 9 is at, this is 1, 2, 3, 4th, 5th or 6th place. 9 is at 4th, 5th or 6th place. So what do we need to do over here? For the first three places there are two choices. Out of these three places we need to choose one place. We need to choose one place out of the three places and put 9 over there. The remaining two places we can fill in 9 into 9 ways, and the unit place we can fill it in 4 ways, because now 9 cannot be there, so 4 ways. So the value for this multiplication is going to be how much? Let's have a look at it. This is going to be 2 into 3 into 81 into 4. So this multiplication is going to be how much? 4 3s are 12, 2s are 24 into 81. So 24 into 1 is 24, and 24 into 8 is 192, 192 and 194. So in the case 1, total 1458 numbers are possible. In the case 2, 1944 numbers are possible. So the addition over here is how much? Over here the addition is 3402. That is option C is the correct answer. The next question is from CAT 2000. 1 red flag, 3 white flag and 2 blue flags are arranged in a line such that no two adjacent flags are of same color, and the flags at the two ends of the line are different colors. In how many different ways can the flags be arranged? So let's have a look at it. So there is 1 red flag, then there are 2 blue flags, and the number of white flags are 3. So likewise total 6 flags are there. So 1, 2, 3, 4, 5 and 6. The maximum number of flags are of white color. The condition is what? 2 adjacent flags, they cannot be of same color. So the white flags can be like this: white, white and white. This is one possibility. The second possibility is white, white and white. But this possibility is not valid because of this second condition. The flags at the two ends, they should be of a different color. This is valid. After that, white, white and white. This is also not possible. The second possibility, the next possibility which is valid, is white color over here, white color over here and the white color over here. So effectively we are having only 2 possibilities. Which 2 cases are there? Let's have a look at it. 1, 2, 3, 4, 5, 6. White flag here, here and here, and white flag here, here and here. So these are the 2 choices we are having. These are the 2 cases we are having. So after this, what we can do over here is 3 places are vacant over here. Okay, 3 places are vacant and the 3 flags are the remaining. So out of these 3 places we will be choosing 2 places. We'll keep blue flag over there, and the remaining 1 place we will be keeping red flag over there. This we can do in how many ways? 3 ways. So over here the 3 white flags, they are 3 identical white flags. So we do not need to arrange, we do not need to do the arrangement of 3 white flags. We do not need to do the arrangement of 2 blue flags. Here also similarly there are 3 vacant places. So from the remaining these 3 vacant places, choose 2 vacant places. Put blue flags over there, and on the remaining 1 vacant place put red flag over there. So this you can do in another 3 ways. So you can do this in total how many ways? 3 plus 3, 6 ways. This is how we can solve this question number 40. Question number 39 is from CAT 2001. Let n be the number of different 5-digit numbers divisible by 4 with the digits 1, 2, 3, 4, 5 and 6. No digit being repeated in the numbers. What is the value of n? So total how many numbers we can form which are 5-digit, divisible by 4 without repetition and by using digits 1, 2, 3, 4, 5 and 6. Okay. So let's have a look at it. 5-digit number. Divisible by 4 means the numbers formed by using last 2 digits should be divisible by 4. So let's list down all the possibilities for the last 2 digits. Okay, by using this list. The last 2 digits can be 1, 2, 1, 6. 2, 0, 0 is not there. 2, 4, yes. 2, 8, 8 is not there. After that 3, 2, 3, 6. 4, 0 not possible. 4, 4 not possible. 4, 8 not possible. 5, 2, 5, 6. 6, 0 not possible. 6, 4 possible, yes. So 1, 2, 3, 4, 5, 6, 7, 8. So we can fill last 2 places in 8 different ways. We can fill last 2 places in 8 different ways. So it is without repetition. So out of these 6 digits, total 6 digits are available. Out of these 6 digits, we used 2 digits for the last 2 places. So how many digits are remaining now? 4 digits are remaining. For the first place, there is a choice of 4 digits, 3 digits, 2 digits. So how many such a 5-digit numbers are possible? 4 into 3 into 2 into 8. That is equal to how much? 12 2s are 24 into 8. 192 is the answer to this question. The next question is from CAT 2002. How many numbers greater than 0 but less than a million can be formed with the digits 0, 7, 8? Nothing is mentioned about repetition, so repetition of digits is allowed. So what do we mean by million? Million means 10 lakh. So less than million means it is a million is a 10 lakh, that is a 7-digit number. So less than million means 6-digit number or even less than that. So let's have a look at it. How many numbers which are greater than 0 but less than a million? So you need to consider how many 1-digit numbers we can form. Then how many 2-digit numbers we can form. Then 3-digit, 4-digit, 5-digit and 6 digits. 7-digit is a million. We want less than a million. We are allowed to use only digits 0, 7 and 8. So how many 1-digit number we can form? The first digit cannot be 0. So this can be 7 or 8. There are 2 choices. So only 2 numbers, only 2 1-digit number we can form. How many 2-digit numbers we can form over here? First place can be 7 or 8, 2 choices. Second place can be 0, 7 or 8, 3 choices. So there are going to be 6 2-digit numbers we can form. Now let's talk about 3-digit numbers. First place cannot be 0, it can be 7 or 8, so 2 choices. Second place, it can be any among 0, 7, 8, 3 choices over here, 3 choices over here, because repetition is allowed. So over here there are going to be 3 into 3, 9 into 2, 18. 3-digit numbers are possible under the given situation. So let's talk about 4-digit, everyone. So 2 choices over here, and for every remaining places there are 3 choices. So 2 into 3 cube, 27 into 2, 54. Let's talk about 5-digit numbers now. For the first place there are 2 choices, and for the every remaining place there are 3 choices. So 81 into 2, 162 5-digit numbers are going to be there. And now 6-digit numbers. First place 2 choices, and for every remaining place there are 3 choices. That is going to be how much? 243 into 2. That is equal to 486. 243 into 2, that is equal to 486. So let's add all these numbers everyone, and this addition is going to be how much? Let's have a look at it. 2 plus 6 is 8 plus 18 is 26. 26 plus 54 is 80. 80 and 162 is 242. 242 plus 486. This addition is equal to how much? 728. So the answer of this question is option C. The next question is from CAT 2002. In how many ways is it possible to choose a white square and a black square on a chessboard so that the squares must not lie in a same row or same column? So we need to choose two squares. One is supposed to be white and the other one is supposed to be black. But we don't want those two squares in a same row or in a same column. So finding this is difficult. But finding those two squares in a same row, same column is easy. Let's have a look at it. So we need to choose one white and one black. They are in a same row. How many combinations we can make? Let's have a look at it. So in a chessboard is a 8 by 8 chessboard. All 8 rows are a distinct rows, or all 8 columns are a distinct column. So out of 8 rows, we will be choosing one row. Now, the row we selected, in that row, total 8 squares are there. 4 of those are white and 4 of them are black. So 4C1 into 4C1, this is equal to how much? 8 into 4 into 4, that is equal to 32 into 4, 128. There are 128 in which you can choose one white square and one black square from a same row. So now same column, the answer is same over here, same column. There are 8 columns, so out of 8 columns choose one column. In that one column total 8 small squares are there. Out of those 8 small squares, 4 are white, 4 are black. We need to choose one white, 4C1, one black, 4C1. So again 8 into 4 into 4, that is equal to 128. So 128 plus 128, 256. This is what we don't want. This is what we don't want. And the total number of ways in which we can choose one white and one black is 32C1 into 32C1. Because total there are going to be 64 squares. Out of 64 squares, 32 are black, 32 are white. So one white and one black we need to choose. 32C1 into 32C1, that is equal to 32 into 32, 1024. Total number of ways are 1024. Out of these ways, we don't want 256 ways. Because in these 256 ways, both squares are going to be in a same row or in a same column. That is what we don't want. So 1024 minus 256, this subtraction is going to be how much? This subtraction is going to be 768. This is how we can solve this question. Answer is option D.